Hi, I'm Jodie O'Brien, and welcome to the second edition of LGDinTECH Insights. We're a video podcast produced by LGDinTECH, a membership consortium devoted to the prime growers of technology-grade diamond material and the researchers and tech product developers that benefit from their use. LGDinTECH is an ecosystem of lab diamond producers, post-growth service providers, tech product developers, equipment manufacturers, and research institutions. So if you're working in aerospace, defense, high-power electronics, laser systems, medical devices, microwave, optics, photonic, quantum, or semiconductors, this podcast is something that you want to listen to. Today, we're delving into one of the most fascinating uses of technology-grade diamond, nanodiamonds, in biomedicine and other fields. And joining us once again is the co-founder and CEO of LGDinTECH, Liz Chatelain. Liz, thanks for joining us.
Hey, Jodie. Thank you for that. I appreciate the intro.
Well, it's so good to see you again. So I have to ask you, tell us a little bit about nanodiamonds and their properties and why they're quickly becoming so important to biomedical technologies. This is news even today.
It is pretty new, and it's really exploded because of the use of grown diamond. There has been nanodiamond before, but very difficult to make natural diamond, and grown diamond is much more suited. And frankly, nanodiamond is everywhere. We're going to talk a little bit more about the medical applications, but it's everywhere, including in makeup, in your maybe in your car oil, things like that. It is everywhere. So grown diamond technology is a science, and it's really amazing. And we're learning more about it. It's getting used more. But the real emphasis that I love is that it's saving lives. So we're going to touch on that so you understand why I'm so excited about the medical application. So nanodiamonds are extremely important to biomedical now and product developing for all sorts of medical applications, mainly because of these properties. So the nitrogen vacancy centers, the NV centers in diamond, and it's biocompatible to human because it's 100% carbon. So I'll get into a little bit more detail about that too. So these properties are crucial to developing the NMRI, the nuclear magnetic resonant imaging. So imaging, we've all used to X-rays, but really deep imaging is coming into its own because of quantum sensing and targeted drug delivery. So instead of just bombarding the whole body with very important treatments and drugs, now we can be very pinpointed. So A, we can use less drugs, but B, it doesn't have to attack or I don't want to use the word attack, it doesn't have to be absorbed by the entire body. So by using things like MNRI, the contrast imaging and targeting ability, nanodiamond can be used to visualize tumors, to visualize disease and disease sites. So treatments can be very, very pinpointed in the body. It's exciting. It's saving lives.
It's fascinating. It's changing the world. And just to listen to you, we're on the cusp of such greatness. So it's exciting to talk to you. And I know lots of people will be tuning in today to hear what you have to say about this topic. Liz, you recently interviewed one of the world's leading scientists in the nanodiamond space, Dr. Olga Shenderova, CEO of Adámas Nanotechnologies, and she had some great insights into what's happening in real time with nanodiamonds in biomedical tech and quantum sensing. Let's take a listen and a watch to her clip and learn a little bit.
So my name is Olga Shenderova. I am a CEO of Adámas Nanotechnologies. So what we do at Adámas, we break diamonds to nanodiamonds. Diamond has spin state connected luminescence. Nitrogen vacancy center, it is very famous center in diamond. It has spin-dependent luminescence. And in turn, spin states are highly sensitive to environment. Changes in environment, they cause changes in spin state. And those changes in spin state in turn cause changes in diamond luminescence. So this yellow powder is typical abrasive 100 micron size particles. They are yellow because they contain nitrogen. After we do electron irradiation of these diamond particles, they become greenish due to formation of so-called vacancies. Electrons knock out carbon atoms from their sites, and vacancies are formed. Due to their spectra, they introduce and light absorption, they introduce this greenish color. And then we do high temperature annealing, about 1000 centigrades, and vacancies start to move, and they find nitrogen atoms and form these so-called nitrogen vacancy centers, which have these interesting quantum properties. So these particles are used in these biomedical applications. High diamond biocompatibility. So they are safe to be used in cell studies or in vivo studies with animals. They don't introduce toxicity. I can mention another application of detonation nanodiamonds in biomedical field. It is drug delivery application. So since particles are tiny, just 5 nanometers, they have huge surface area. So 1 gram of such particles have surface area of 400 square meters, which is huge. And so you can upload a lot of drugs on such huge area, right? So beauty of diamond surface is high electrostatic interactions of diamond surface sites and diamond surface groups with different drug molecules. So they can be attached just electrostatically to nanodiamonds, delivered to a site of interest using targeted delivery. And then they start slowly release drugs. Another very interesting application I would like not to forget to mention is MRI imaging. In this case, we turn back now to fluorescent nanodiamonds containing NV centers. So there is very interesting technology developed by scientists from UC Berkeley, Ashoka Joy Group, based on so-called hyperpolarization of cis-13 spins. So now we talk not about electron spins of NV centers, but nuclear spins of cis-13 atoms in diamond lattice. But still NV centers are required. It appears that by shining light on NV centers, they become hyperpolarized. Hyperpolarization is alignment of spin in certain direction. As cis-13 spins become hyperpolarized, they become highly visible in cis-13 MRI imaging. So diamonds, optically hyperpolarized diamond can become contrast agents for MRI. As you shine light on them, they become visible in MRI.
I really found Dr. Shenderova inspiring. She's been at this a long time. She was a professor for a while, and she really understood when nanodiamonds became so prevalent and accessible, the potential that it could help people. So it was really quite interesting, and I invite everybody to go to our website and see more of that interview. I think that some of her product developers, at her team at Adámas Nanotechnology work with, they know the importance that nanodiamond can bring in the medical application. So they're really working on innovations, frankly, every day of the week. So it's been really exciting. There are some other sort of incubators all the way through full-blown multi-million-dollar companies out there specializing in nanodiamonds and specializing in medical application for nanodiamonds. So just to explain a bit more, here's some very special scientists at QT Sense in the Netherlands discussing their groundbreaking work using nanodiamond in biomedical disease detection with their Quantum Nova device.
Many major diseases like cancer, cardiovascular, neurodegenerate, result from cellular dysfunction and damage leading to elevated stress levels within cells. This stress is largely driven by mitochondria through the action of free radicals. But free radicals are short-lived, unstable, and in low concentrations, making real-time detection a major challenge for conventional fluorescent dyes. That's why we developed Quantum Nova, a precision device that measures free radicals in real time inside living cells.
Quantum Nova operates at frontier of technology. Our quantum sensors based on the nitrogen vacancy defects inside the nanodiamonds, which detects the minute fluctuations of the oxidative stress or molecular interaction at cellular level by translating them into precise T1 relaxation curves. With this, we will be able to track the cellular responsive with unmatched sensitivity.
The key advantage of the Quantum Nova is mainly the speed and scalability of the device. What we can do with the Quantum Nova is to measure cell activity real time, also preserve the viability of the cell, and at last also we can scale up and do it in high throughput.
Our mission is to touch more than 1 million patients in the emergency departments in the hospitals worldwide. At the same time, we also want to empower the scientists within the pharma and academic research. By having this precision device, one can have a better understanding of cancer, immune response, and disease progression over time.
I thought the last part of that video clip really says it all. Their mission is to touch more than 1 million patients in the emergency departments and hospitals worldwide. I cannot even fathom that. And they also say by having this precision device, one can have a better understanding of cancer, immune response, and disease progression over time. That right there can change not only our lives, but the lives of our family members. I mean, it touches home. So, Liz, what are some other applications using nanodiamonds in science that are already in use today?
That's right. Another life-saving application already in use today is targeted delivery of medicines. Since nanodiamonds are so tiny, they're actually 5 nanometers, but they have very huge surface spaces because they're sort of like a seed. You know, they're like a tiny seed, so they're all surface space. And on this surface space, medical technicians and doctors can upload significant quantities of drugs. So these nanodiamonds, which are biocompatible, can be used to actually just inject right into the body without any kind of toxicity or rejection. And they deliver right to the specific targeted area, which I mentioned before. So why is the rejection rate so low? It's because diamond is 100% carbon, so it's a natural material. We're not putting plastics into people's bodies. So it really makes a difference. Why don't we hear more from Dr. Shenderova in this next clip?
Another example where our nanodiamonds are used for quantum sensing application is a company called Phoebe Technologies in Australia. It was started by David Simpson. That company is focusing on very accurate detection of iron in our blood. And there is no accessible instruments now to detect iron itself in so-called ferritin. Ferritin is a protein where iron is stored. And for example, when there are inflammation in the body, a lot of ferritin without iron is produced. And then it can be a wrong diagnosis that, somebody has a lot of ferritin, but it's empty ferritin. That company is focusing on assessment of iron in ferritin.
In case some of our listeners don't come from that material science world, tell us about the material properties of diamond that make it so important to tech and scientific applications.
Really good question. So the basic inherent property of grown diamond include, now I'm going to list a bunch of areas here because, there's going to be a lot of different viewers to this podcast. So number one and foremost is 100% carbon, as I mentioned before, because when you're embedding that into people, especially who are already in a medical situation, you certainly don't want rejection. The other thing I can't say enough about, and this is something I needed to learn, and that was wide band gap. Now, most engineers out there understand what that is, but grown diamond has the absolute best natural wide band gap. And within those gaps, you can do a lot of different things, including doping and just a lot of things to the diamond that help it be used in multiple applications. Then it has outstanding electrical transport. So now we have wide band gap, we have outstanding electrical transport. This is something so crucial because electricity and battery is becoming just overloading us with everything that we want to use going forward. And so grown diamond is going to help us get there. And don't forget, diamond, just like natural diamond, grown diamond is the hardest material known to man. So when you think of space, when you think of something that's in a very harsh environment or defense, you need the hardest material. And the hardest material doesn't wear out like any other material that we're manufacturing around the globe. Then we have thermal management, and we also have thermal conductivity. This is really, really important when you're talking about high-powered electronics. Why? Well, unfortunately, the onset of EV cars, which, we love, it's much better for the environment, but they can catch fire. You have this deck of batteries at the bottom of that car, and they can, in very rare cases, catch fire. Well, for fire to start, you have a very pinpointed hotspot, and then it can flame up. Well, diamond stops it from flaming up. Why? Because of thermal management and thermal conductivity. Thermal management means diamond is a great heat spreader.
Liz, this may not be, the most ideal time to bring it up, but I think it is. Honeywell. This story that just came out of Honeywell recently securing significant U.S. Defense Department contracts. And this is to help them develop that quantum sensor-based navigation systems. This could replace GPS. What are your thoughts on this latest news?
It's incredible. They first of all, they didn't start off to try to replace GPS. They started off to try to be more accurate than GPS. And because of the use of grown diamond, it is more accurate than GPS. And when you're working in defense, we all realize you've got to be extremely accurate. But commercial aircraft need to be extremely accurate. Everywhere, everything needs to be extremely accurate. If we're sitting in our EV cars and we put it on autopilot and we're trying to go A to B, we need to be extremely accurate so we don't have accidents. So this new use, and it can only happen because of grown diamond, you're right, it could replace GPS. It's just an extremely better alternative. It's still in the development phase, but I'm going to monitor it very closely.
Well, what great confirmation that, to have a government contract, that's pretty big confirmation that we're on the cusp of something just unheard of. And exactly where your research and where your power and your excitement is. So I love that. Well, we all know that technology-grade grown diamonds, they come in very different shapes and sizes compared with gem diamonds. If our viewers want to see some samples in person, how can they do that?
Well, first of all, we do have samples, images on our website. And if people, engineers and scientists, product developers of all types, would like to see and touch and feel and discuss with actual growers, they can come and meet us at our next trade show is going to be Semicon West, which is in Phoenix, Arizona in October 7 through 9. We have a pavilion, 1851, and we'll have growers there. We'll have scientists and engineers there. We'll have post-growth treatment companies there. We'll have lots of brain power in our pavilion to answer questions, to make connections, to really help everyone advance. And why do we pick Semicon? I mean, the semiconductor industry needs, frankly, to incorporate even faster grown diamond because more and more is being asked of an average semiconductor. And the materials that we've been using, which have been great until now, they're not next gen. Silicon is not next gen. Graphite is not really next gen. I mean, we need something that's going to last longer, that's cheaper, that's smaller, but can do more heavy lifting. And so that's why at Semicon, we'll be talking to, designers, engineers, manufacturers of all sorts of semiconductor business, but also at Semicon, they attract, everybody in the high-powered electronic area. So it's going to be great, and we'll have some very leading members there from our group.
Tell us your booth number one more time, because I know that is going to be the best booth at the conference, like the most fun. So tell us what the number is one more time.
It's 1851, so 1851. It's a pavilion. I'm sure we're easy to find.
Liz, how does membership in the LGDinTECH Consortium work?
So the consortium itself, our membership consortium, and you can imagine a consortium is like an ecosystem. So each different level of diamond is represented. So you have growers, you have post-growth service providers, you have engineers, you have scientists, you have government officials, you have investors, capital raising organizations, promote. I mean, it's a real ecosystem to help, speed up the use of diamond, of grown diamond. Again, we started this whole podcast talking about how it's saving lives. Well, it can save lives in many different ways, not just medical application, but we talked about, things like EV cars catching on fire. So it's really an important element, and it's going to help upgrade every application that's out there. So the consortium's ecosystem, we want everyone that could touch diamond, grown diamond, to be a member. And we always tell people in the industries, all the different industries, we really focus on 10 different industries. So you have aerospace, defense, high-powered electronics, laser, medical devices. We talked about microwave. We haven't talked much about optics, photonics, quantum sensing. We talked about quantum devices, and of course, semiconductors. That's why we're at Semicon. But really, what does diamond do? It helps the functionality, longevity, safety, and sustainability of every application it's put in. I haven't even touched really about sustainability, but grown diamonds are that. They're grown, and you need a lot of energy, but that energy can come from sustainable sources, which most diamond is grown that way through solar or hydro or whatever the sustainable sources. And it lasts forever. Okay, I'll throw that out there again because I think that's really, really important.
Well, we were thrilled last month when the premiere edition of this show, our podcast, got over 1,200 viewers watching it. We've had so much great response. And so, of course, Liz, after last month's premiere edition, we got our inbox completely filled with questions from viewers. And so I thought today we could challenge you a little bit and see if you could answer some of these questions. So let's see how good you do. The first question came from a diamond grower. And this person asks, we have been very successful in growing diamonds for the gem and jewelry space. Sound familiar? But we are struggling a bit switching our chambers over to growing technology-grade diamond. What would you recommend to help us get going?
So that's a very, very good question. We actually posted on our website some mechanical images and backed up with actual applications of what they do need to do. And we have some consultants that are part of our ecosystem that we can introduce them to that specialize in this actual step. I will say to growers, when you switch a chamber, let's just say a CVD chamber, to grow for tech, you will not bring that chamber back to grow for gem. It's a different set of gases, and other things need to be augmented to the chamber. So most of our growers usually start with, say, 25% of their chambers. They convert them. They perfect their diamond growing. We build these relationships with actual users, and then they work together as part of this ecosystem to come up with what the application is going to be and what the tech company needs. And then from that 25% of chambers, then they'll go to 50 or et cetera. So the chambers themselves do need to be augmented a bit. And we do have information on our website. And of course, they should become a member of LGDinTECH. And then we can link them up directly with experienced consultants.
Like you said, that's one reason why you have the ecosystem, so that people who have questions like that can connect with experts in the field and solve these issues, whether they be simple or complex. So wonderful. Join the ecosystem is what I would say. Well, here's another one for you. Are technology-grown diamonds being used in satellites and rocket ships?
Yes, they are. And I sort of touched on this earlier because it's harsh environment. Harsh environment eats through everything. Again, if you're up in space or at the bottom of the ocean, the environment itself is really, really hard on all the component parts. Between just the arrangement of where it is, but also all the different parts have to sync exactly right all the time and function all the time. It's not like a factory floor where you go, oh, this machine over here is acting up, just go over, unplug it or replace something. You can't do that usually in harsh environments. And so you need something extremely hard, and diamond is the hardest material known to man. So there are certain areas where a harsh environment is super, super important to use diamonds. So technical grade diamonds are currently being used in space. They're coating, critical aircraft components because of the harsh environment. They're coating it with diamonds. The electrical components, again, we talked about heat sink and heat spreader. You definitely need those. You can't afford a fire anywhere. And you have to be confident that your component parts are working. And that's what diamond really gives. And I didn't grasp that until we had this engineer who's a member of our group. He said, when you're up in space, you have to be so confident that everything's going to work. An added feature is diamond is lighter weight than most other materials. Diamond is super, super hard, and it's lighter weight. And in aerospace, that is so important. Weight is everything. So it's lighter weight, and that's very, very exciting.
Wow.
And by the way, for all my sci-fi favorite things, there's space elevators. Now, I'm not going to say I know what the heck that's going to bring us, but isn't that a great term, space elevator? I love it. So nano diamond threads that are like key components to develop these space elevators. We got to monitor this. This is going to be really exciting.
Well, obviously, people who are even remotely interested need to join the consortium so that they can get a feel for what the possibilities are. But can you tell us a little bit more about the scientists and the tech experts LGDinTECH has available for consulting with diamond growers and product developers?
So we have worldwide, we have a range of scientists and engineers who have signed up with us, who have worked with members, who grower members and product development members. It's really quite fascinating. And it's very, it's broad, because I mentioned we have these 10 different 10 different categories of product out there that we're focused on. And within each one is just hundreds of subcomponent parts. So we're building our group of consultants. And if a company member can come to us and they need a specific service, or they need a specific information, or they want to, collaborate, we can help introduce them to the right venture partner, either a scientist, engineer, or another company, so we can help build those relationships. Using grown diamond is our goal. So through partnerships, directly and indirectly, where we're involved, is just crucial to the whole success of our ecosystem.
Well, today has been fascinating. Thank you again for helping us to learn so much about technology-grade diamond and how it's just changing the world. We obviously want to thank our viewers and listeners for joining us today. We will be back, so don't worry, with the third edition of LGDinTECH Insights in just another month's time.